explain the problem of mosaic single cell data integration. So with their approaches, they introduced by UI NMF and binary multi-map. So in a way, I will be like stabbing behind their backs by introducing a much better model StabMap, which came in around February 2022, and it actually is quite different from those two methods who are very much dependent on the intersection of all the common all the data sets. So the common features in a way enter the accuracy to which the data integration can actually go. So StabMap uses a thing called data topology, mosaic data topology, to counter that, and it actually surprisingly works well when the quantity of overlapping features is minimal. So we'll see it now. And so the importance of data integration has already been discussed, as a lot of downstream analysis surface from there, and we are able to get a lot of inferences from it. So StabMap is a very flexible approach and uses a mosaic data topology, which can either utilize supervised learning or unsupervised learning to actually learn the embeddings, and it does it by traversing in the along the shortest path in a topology. So the key feature which I already highlighted was that it is even beneficial when there is a disjoint. The problem is of disjoint mosaic data integration, and it enables the use of novel spatial gene expression features for mapping dissociated single cell data into into a reference in a single coordinate space. So with that introduction, let's briefly discuss the methodology. So yes, so as we've already discussed that it uses something called mosaic data topology. So to briefly understand it, so if you have many different data sets and they have some overlapping features, some are not. What it actually does is that instead of using some kind of the intersection part and then having these as learning these in some sort of latent variables, it actually constructs a graph out of all those data sets. So in this way, and it tries to it tries to give weight to the edges on the basis of the amount of overlapping features. And as we can see, there can be some edges which do not exist because these two might not have any single common feature, which is not the case which multi-type and dual NMF can work on. So let's just say that we have one reference data set, and these two are derived from it. So I have constructed two edges, the way it's representing the amount of overlapping features. So okay. So what it now tries to do is that initially, to just give a brief of the mathematics, I will not go into detail. Let's just say that these data sets are D1, D2 and D3. So firstly, it tries to learn some of the feature matrices using something like as I already stated before, that if the cell labels are provided, we can use supervised approach like LDA for dimensional D reduction. Otherwise, something like PCA would be used here. So in either case, what we would ultimately get is some kind of feature matrices, say for first dataset S1, which can be written as transpose of D1 times T1. So this is what actually are the features which we get from here, S1, S2, S3. But this is not what we want. We want some to club these these matrices in some way that they amalgate to form a common feature set. So how it does it? That starting with, so the just brief it out. Yes. So as we have already discussed that S and A are the features decided. So yes, I'll come on to the figure itself. As so we have right now we are at this stage. Now what happens? So the closest one with which it has an edge. This can there can be two cases here, that either these features are already present in this. So in some way that this set is just, this data set is kind of subset of the reference data set. In that way, we can simply project the relevant columns onto the S1 and get the desired S2. But that may also not be the case. In that case, it tries to fit a multivariable linear regression model, and then tries to learn the features of S2. But what in the case of some other data set which is not actually connected with say the reference data set S1, so S3. So in that case, you can easily you must all many of you must have seen that there is a path here, and it's a very simple example in which there are only 3 nodes. But if there were many one, we would take the paper actually takes the shortest path to actually learn the features. So what it does is that it uses S2 as a temporary reference data set and then maps S3 to S2, and then ultimately S2 is back, mapped back to S1. So in a way, we are ultimately all things are done with respect to S1. So as the figure also states, you can see here that query data set can easily be projected, but then this is done in an intermediate fashion. That firstly the data sets of the cell represented by yellow are mapped onto blue, and then these are reversed back into yellow, ultimately giving us that reference coordinate. But there might also be the case when there are so many data sets that we do not actually want one reference data set, because that will introduce some kind of bias. How are we going to decide one reference data set? And this paper actually tackles that problem very well. That okay, don't take one reference data set. So in this example, they have taken all of them reference data sets one by one. So this is the embedding which is learned when red is the reference, this is in blue, and similarly yellow. So ultimately, it then assigns some kind of weight, and the paper actually uses user-defined L2 norm reweighting to actually incorporate the embeddings from all those data sets, but in a weighted fashion, and it tries to form a new set of weights. And these weights, I think in this example they have kept it 1 by 3, 1 by 3, but that can be tuned according to some other kind of analysis that that this data set should be the more reference data set. So as you can see, the approach is kinda intuitive and easy to grasp, and ultimately this is the crux of what the paper does. But from here the inferences are very important. But before that, coming to the evaluation part, that how we are actually determining that a model is good. So the paper uses only 3 metrics. There is one more fourth metric, but that is not comparable because UINMF and approaches like multivariate actually uses a common set. So that metrics actually works when there is a common set. So instead it has used some other 4 which we will cover. So one is basic cell type. One is basic cell type classification accuracy, that you have made some reference data sets. Now you are artificially relabeling them and trying to use KNN. So they have used K0 and then relabeling and assigning them to clusters and checking the classification accuracy. Obviously, higher the better. Then secondly, Jacquard similarity, and Jacquard similarity, as you already know, that it's the for 2 Venn diagram type sets, it is basically the ratio of intersection upon union. So higher the better, because it signifies that there is much more overlap of features. And thirdly, the number of nearest cell matrix, that if my own cluster cells are actually nearer to me than some other one. And finally, to analyze and to actually evaluate the disjoint case in which the intersection of all 3 is null set, it uses something called local inverse Simpson index, which takes cell type and modality into account while calculating. And higher the LISA value, the better. I was not able to actually figure out the mathematics behind it, but this is one metric this paper uses. Finally, the results were comparatively much better than UNMF and multi-map approaches. The StabMap was able to preserve cell-cell relationship in the multiomics data, as well as as I already stated in the starting, it was superior when the non-overlapping features were actually much higher. And finally, thirdly, this plot is much able to give you the idea of what the paper is doing. So in this you can see that cell type accuracy metric. So StabMap supersedes multi-map, which again supersedes UNF, which is obviously better than a naive implementation of PCA. Similarly, we can see Jacquard similarity and other features and plots. So with this, finally this just to summarize. As we have seen that we are learning S1, S2, and S3 new features after iteratively some fitting some multivariate model. Ultimately, the final feature set is simply catenation of S1, S2, S3. But the paper says states right there that this is not the ideal thing which they should be doing. It is called basically vertical integration of columns. So it suggests that some other techniques such as feature standardization and it states the vertical integration methods which were used actually in some other papers in MOFA or sharing information across multiple layers, and these could have been given much better results in actually integrating the features which you have collected from different nodes. So this is one thing the paper suggests, and with this I come to the end of my presentation of StabMap. Thank you.
Okay, so we'll go to the next topic. And let's actually stop today after